Hello and welcome to Exponential Growth and Decay Day. So we have talked about exponential growth and decay in relation to how our graph looks, but now we are going to actually be writing the equations of growth and decay functions. So we're going to start with exponential growth, which occurs when a quantity increases. Makes sense, right? It's exponential growth by the same rate over time, okay? And so we have our equation y equals a, parentheses 1 plus r, end parentheses to the t. So this time our t is our exponent. And luckily our a is still going to be our initial rate, or initial value, excuse me. And then our r is going to be, that's right, you guessed it, it's going to be rate. Which means that our t is going to be time. All right. Now, something important to notice about our rate is that we need to make sure that we put it in decimal form. Okay? So our rate has to be in a decimal. Alrighty, so let's take a look at our first example. The original value of an investment is $1,400 and the value increases by 9% each year. Write an exponential growth function to model the situation, then find the value of the investment after 25 years. So let's start by listing out what everything is. So our initial value is going to be the $1,400. Our rate is 9%, but we need to change this into a decimal. So in your calculator, let me make sure that we can actually see our lovely calculator. Here we go. We are going to type 9. If I can actually press the button. There we go, 9. And then we are going to press second. And then we're going to press this parentheses button because if you see right above it, it has a percent sign, which gives us the 9%. And if we press enter, it gives it to us in decimal form, which you can't really see because this calculator is awful, but it says 0.09. So here we're going to put 0.09. And that's what we're going to use into our equation. And then finally, our t, our time, is going to be the 25 years. Alrighty, so now all we have to do is substitute our information into our equation. So we have y equals 1,400 parentheses 1 plus 0.09, and then to our t, which is 25. All right, and so then back in our calculator, we're just going to type that exactly as we see it, okay? So let's put them side by side so that maybe we can see everything. There we go. So we have 1,400 parentheses 1 plus 0.09 end parentheses to the 25. And that's going to give us $12,072.31. Beautiful. And we're done with that problem. Okay? So now let's take a look at the next one. College tuition at a college is $12,000 and is increasing at a rate of 6% each year. Write an exponential growth function to model the situation. Alrighty, so also on your quiz and or test, it's not going to tell you that it's exponential growth or decay. So you have to use our keywords like increasing. And it also said it increases on the first problem. Okay? Let's zoom back in a little bit. Alrighty, so let's take a look and let's define our variables. So our A is our initial value, which is $12,000. Our R is 6%, which if we change into a decimal, 0.06. And then our T is going to be our time, which is 4 years. Okay? So now we write y equals $12,000, 1 plus 0.06 to the fourth. And then you will just type that into your calculator and tell me what you get. I'm waiting. I'm actually typing it in myself, which is what is happening right now. I will show you. 0.06, and then to the fourth, which will give us that amount. And so then we're just going to write it here. Good. Alrighty. And then for number 3, number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. Exponential function. Find the number of student athletes after 5 years. So our A is 300. Our R is 8%, which turns into 0.8. And our T is 5. So then Y equals 300, 1 plus 0.08 to the fifth. Alrighty, and I'm going to let you guys tell me what this answer is. So go ahead and write it. Alrighty, so then, hopefully you got that answer right. We're going to move on to number 4. So for number 4, we have annual sales for a company is $149,999 and increasing at a rate of 6% per year. Write exponential growth function to model this situation. All right, so you guys, what is my A? It is the really big number, and then our R is 6%, which changes into 0.06, and then our T is 7. Okay, so, whoops. All right, so how about you guys write the equation, and then I will give you an answer, and then that way you can determine if you wrote your equation right or wrong, okay? So you guys write it right now. Okay, so you guys got your answer for your equation for number 4, so let me give you that answer. All right, so once you typed it into your calculator, you should have gotten 225,543.03. All right, sorry, numbers are hard. All right, so let's look at number 5. Population of a small town is 16,000, increasing at a rate of 3% per year. Write the function, then find the population after 10 years. So again, also all of our keywords, increasing, and we're still increasing. Okay, alrighty. So our A is 16,000. Our R is 3%, which is 0.03, and then our T is 10. Alrighty. So we can just write that equation. And then we'll get our answer. And our answer is that. So hopefully you got that. And now we're on to number 6. So how about you guys do number 6, and I want you to write the equation and give me the number. Alrighty. So now that you guys have completely answered number 6, we are moving on to our back page. Alright, we are now working with exponential decay. So exponential decay occurs when a quantity, that's right, you got it, it decreases. So that's going to be the main difference between growth and decay. because, I'm going to spread this back out, if we look at our growth, it occurred when a quantity increased. And so because it increased, we added. Now that our quantity is decreasing, we are going to subtract. But don't worry, because our A, our R, and our T are still all of the exact same thing. So A is still our initial value. R is still our rate in decimals. And T is still time. Okay, so then let's try number 7. So population of a town is decreasing. Hey, that is our new keyword. At a rate of 1% per year. In 2000, there were 1,300 people. Write the function to model, then find the population in 2008. So our initial value, our A, is 1,300. Our R is 1%, which changes into 0.01. And then our T is interesting because our starting time is 2000, and we want to find the population in 2008. So in order to find T, we are going to do 2008 minus 2000 to get our T equals 8, because that's how many years has passed. And that's also how you should have done number 6. Alrighty, so then we are just going to write y equals 1,300, 1 minus 0.01 to the 8th. And then just like we did before, we are going to type it into our calculator exactly as we see it. So we have 1300. Whoops, that's supposed to be a 1. And you should get 1,199.56. Whoops, there we go. Alrighty. So then for number 8, value of a car is depreciating. That's our new word. At a rate of 12% per year. Write the decay function to model the situation, and find the value of the car after 10 years. So we have our A is 18,000. Didn't we talk about depreciating cars? Yes, we did. All right, we have our rate, which is 12%, which changes into 0.12, and our time is 10. Okay. Alrighty, so now we have y equals 18,000, 1 minus 0.12 to the 10. And so now you guys are going to give me that answer. Okay, you ready for it? Give it to me. So now that you guys have given me that answer, we are going to move on to number 9, where a farmer buys a tractor for $50,000. If the tractor depreciates by 10% per year, write the, depreciates, write the function after 7 years. So our A is our starting value of 50,000. Our R is 10%, which is 0.10. And then our T is 7. So we have y equals 50,000, 1 minus 0.1, 0 to the 7, which is going to give us, let's put it into our calculator. So we have 50,000, 1 minus 0.1 to the 7. All right, so that's going to give us, that number, okay? So equals 23,914 and 84. Okay. Alrighty. For number 10, an investment loses. So that's a new keyword, loses value. at a rate of 2% per year. Write the exponential decay. Find the investment after 9 years. All right, so our A is 8,200. Our R is 2%, which is 0.02. And our T is 9 years. So how about you guys write this equation, and then I will give you the number. So go for it. Alrighty, so I'm going to give you, and you should have gotten 6,836.73. Okay, so that's what you should have gotten from your function. Alrighty, let's take a look at number 11. The value of a book is $58 and decreases at a rate of 7% per year. Write the decay function after 8 years. So starting value is 58. Our rate is 7%, which becomes 0.07. And our T is 8 years. Alrighty, so Y equals 58, and then we have 1 minus 0.07 to the 8th, and then that will give us $32.45. Alrighty, and so finally, I'm going to have you guys do number 12. Sound good? Awesome. So you guys do 12 right now. Alrighty, so now that you guys have done 12, hopefully you understand growth or decay. If you do not, now is a great time to ask me for help. Otherwise, it is time for you to do Delta Math.